All right, folks. We are going to continue on your notes today. We're going to do a little bit of color coding. So for some of you that might be more visual, hopefully this will help you a little bit. Okay. We are going to basically make a key or a legend. You guys all know what those are on a map, right? Okay. With our colors for the things that we're going to be finding today. Okay. So what I need for you to do is on the front of your page, you have the word positive down there in those boxes. Please circle that with red. We're going to mark that with red when the graph is positive. Okay. For negative, let's mark that with blue. So please circle the word negative with blue. Okay, now what does it mean to be positive, folks? Above 0, and the horizontal x-axis is 0, correct? Okay, so I want you to take your pencil, and in red, I want you to trace the part of this graph that is positive, that is over the x-axis. Then I want you to pick up your blue pencil, and I want you to trace where it is negative with your blue pencil. How is that for everybody, okay? We sure? Okay. Then we talk about increasing and decreasing. Increasing is going to be green, so if you would like to circle that. And we are going to circle the decreasing with orange. Everybody doing all right? So take your pencil, your green one, and we want to know where this thing is going up. Remember, we read this from left to right. So wherever it is going up, we're going to trace that with green. Is that okay for everybody? Where it is going down, we're going to trace that with orange. That would be decreasing. Any questions there for me? Okay, so those are the 4 things that we're going to color code today. Sound like a plan? Okay, so we're going to get through as much of the notes today as we can. We won't get through them all again, and then you're going to have one problem for homework where you have to label and find everything. Okay? Well, we'll see. You are going to color, yes. And if you don't have colored pencils at home, you are welcome to take mine. Actually, they're not mine. They're other teachers that have colored pencils in the building. But you need to bring them back so I can return them to them. Okay? All right, so I believe we did numbers 1 and 2 already. I also believe that number 3 did not copy. Like, I think it's a big blank spot where there's number 3. But that's okay, because that just gives you some room to write, because we're going to need to write quite a bit. So I'm looking at number 4. I think Cody's yours copied because I made your copy yesterday. Okay, so take a look at number 4. The first thing I want you to do is I want you to look at the graph. I want you to look at all the titles, the x-axis, the y-axis, the title of the graph. I'm on number 4. And I want you to tell me about what's happening here. What is going on? What's the situation? Yesterday we launched an object. Yesterday we thawed something. What's going on in this situation here? What does manufacturing mean? I am making something. They don't tell me what it is. They just say units, right? Okay. Now I want you to look at what's happening here. You see this like little U shape? So the question says, describe and interpret any symmetry. What does symmetry mean? Go ahead, Brayden. Straight through the middle. So I cut it in half. If I folded it up, it would be right on top of each other. Do I have that here? Can you draw a line, please, where the symmetry happens in your regular pencil or pen, whatever you're writing with? Hopefully, you see that symmetry happening right here. Cuts it right in half, doesn't it? What kind of a line is that? And don't tell me straight, because all lines are straight. That is a vertical line. Well, it can't be nonlinear because that thing is a line, isn't it? Okay. Now, I want to know about this line. I want to know what all these points are. Can somebody tell me one of those ordered pairs? Which one is it? This one is 30, 0. Keep going. Good. So what do you notice about every single point on that line? They all start with what? So what variable is 30? Is that the x or the y? That's the x. All of your x's are 30. Okay? Every x is 30 in this symmetry. Okay, but it also says describe it. So what does it mean, folks? I don't really need the coordinates anymore. I'm going to get rid of all those. Whoops. What are we doing here? No, you don't have to. I just wanted to show you that all those x's were 30, okay? So tell me, what's happening? Why is it symmetrical? What's going on here? It's okay. Dalton, can you shut the light off for me, please? Go ahead, Trevor. Kinda. If it's symmetrical, what do I know about this side and that side? They're the same, aren't they? Okay. Where does it switch over? Where is my symmetry? 30 units, right? So it costs the same before 30 units as it does after 30 units. Everybody agrees this is 30 units right here, yes? Is this curve the same as this curve? Yes. This side over here is before 30, isn't it? This side over here is after 30, isn't it? So that's what our symmetry means. It costs the same before 30 units as it does after 30 units. If this is my company and I'm making whatever it is that I'm making, how many units do I want to make? What's going to get me the most profit, you think? If it cost me this curve, where would it be best if I'm the boss to tell my workers, I want you to make this many of them? At 30, right? Folks, because my cost at 30 is the lowest it's ever going to be, isn't it? My cost at 30 is as low as it's ever going to be, right? So as a boss, I would want my cost to be low, right? And then hopefully I sell a lot of them and I can make my money back. How is that for everybody, okay? You sure? That's the only symmetry problem I'm going to do. We're okay with symmetry. Okay, let's move over then. Let's make sure you remember what intercepts are. So I want you to look at your graph, look at your titles. I want you to tell me what's happening in this situation. Just what's the situation in general? What are we talking about? Go ahead, Trevor. We're talking about college costs. Credit hours. Credit hours are classes, folks. What happens as I take more classes? The cost goes up, doesn't it? Okay. All right, so tell me, is this thing linear or nonlinear? Okay, easy enough. Okay. What else does it ask me to find? The intercepts. I have x-intercepts, I have y-intercepts. Let's do x-intercepts first. Remember, the x-intercept is where a line crosses the x-axis. No, just in your regular old pencil. Where it crosses the x-axis. Where does this graph cross the x-axis? This is the x-axis, right? Does it ever cross that x-axis? No. There is no x-intercept. Somebody tell me why. In this situation, why is there no x-intercept, Quentin? Not because I can't go negative. I can't go to 0. Folks, yeah, there's always a starting cost. What is my starting cost here? $50. I'm never going to be at 0, right? Even if I don't take any classes, it looks like I have some sort of registration fee or a service fee or something of $50. Okay, does that make sense, everybody? So if I'm going to interpret this, basically it means it will never cost $0 because there was no x-intercept. All right, how about the y-intercept? Where does this graph cross the y-axis? $50. What is that ordered pair? 0, 50. So what does this mean? Interpret it. We actually just said it. Say it again. You start at $50 no matter how many classes you take. And then it looks like it goes up by there from there. Questions for me here, folks? Intercept's what we talked about yesterday. Agreed? Yeah? You sure? Okay, so let's get to the big problem now. You see that one down there? Okay. The first thing I want you to do is I want you to take your colored pencils, and you have a bunch of white space up top, don't you? Okay. I want you to make a key at the top, but I would tell you to write it small because we're going to need to use that white space for all the stuff we have to write. Okay, so in that white space, you're going to say, actually, you know what? I don't think we need to do that. I think we can just circle it. Does that sound okay with you? Oh, we could do that too. Whatever you want, whatever's best for you, okay? What's the situation here? What's going on here? We're selling video games, aren't we? And we're starting at 2000. Okay, what's the first thing they want me to find? Estimate and interpret where the function is. And aren't we using red for positive? Okay, so go ahead and circle that. Red. What does positive mean again, folks? Above the x-axis. So take your red pencil, and I want you to trace that curve where it is above the x-axis. So, can you tell me where this thing is positive? Give me all the values for x where this thing is positive. Well, you can't possibly give me all the points because there's infinite points, yes? Where does it start out being positive? Where does it end being positive? It looks like -1 over here, yes? But folks, we're talking about years since 2000, right? And if you tell me -1 and I'm supposed to start at 2000, what year would that be? 1999. So we're going from 1999 to what? What's that? 2001 would be right here. Where does it stop being positive? It's like halfway between 10 and 11, isn't it? Okay, I can't say 2010.5. So what do you want to make it? Do you want to make it 2010 or 2011? Okay. Now, if you really wanted to be good, you would say like the summer of 2011, because wouldn't the summer be like halfway through the year? Okay. Or the summer of 2010, excuse me, would be halfway through the year. Okay, well, Next, let's look at negative, and we're doing blue for negative. So take your blue pencil, circle that word negative, and now take your pencil and trace where this function is negative. What does negative mean? Below 0, which would be here and there. So where is it negative, folks? 2010. Well, we said that was 2011, didn't we? Am I going before 2010 or after 2010? So it is negative after 2011. And before what? And before 1999. Guys, this should make sense that I'm using the same years, because as soon as it stops being positive, then it starts being negative, doesn't it? Doesn't that make sense how they should match up like that? Okay. What are they asking me for next? Increasing, and we're using green for increasing, so if you would please circle that. What does increasing mean? Going up, and how do I read things? So if I look from left to right, I am not paying attention to the arrows. I want you to take your green pencil, and we're going to circle where the graph is increasing. So does it start out increasing? Yes, and it's going to stop increasing, I don't know, maybe right about there. Is that okay for everybody? Yeah. Does it increase again? Yeah, maybe right about here it starts increasing to there. That's where it's going up, yes? Can you tell me where that is happening? How would you describe this first green circle? Gotta speak up, I can't hear you. Well, is it just 1999 or does this thing keep going? I know, but I'm asking, what about 98? Would it still be going up at 98? Yeah, 95? Well, this arrow tells me it's going to keep going and going and going, right? So it looks like it stops increasing at 2002. So how would I describe that? Before, this would all be before 2002, wouldn't it? Okay, so we're going to say before 2002. Where else is it increasing? Where else is it going up? Yeah, 2004 up until 2008. So then 2004 to 2008. Does that make sense to everybody? Yeah? Kinda. So it starts going up at 2004 and then it stops going up at 2008. All right. What else are they asking me for? Decreasing, and we're doing orange for decreasing. Take your orange pencil and circle the portions of the graph where it's going down. You got those circled okay? Okay, so how would you describe the first orange circle? Go ahead, Savannah. Say it again. Where does it start? It starts going down in 2002, doesn't it? And then it stops going down in 2004. 2002 to 2004. Does that make sense or no? I am not including an increase. The increase starts at 2004. Is that okay? Do you guys see how this 2002 and 2004 matches up down here with 2002 and 2004? Because if it's not increasing, it's probably decreasing, right? Unless, of course, it's a straight flat line. That's really close to being a straight flat line. Really close. How would you describe the other orange circle? After 2008. And again, that 2008 date matches up over here with my other increasing date. How we doing? Is the visual helping you with the colors? Okay, a little bit. What do they ask you for next? Yeah, you can ask a question. Go ahead. Because this arrow, there actually is an arrow underneath there, and it's going to keep on going. Yeah. Mm-hmm. All right, what else are they asking me for? X coordinates of what? What are extremas? Or, okay, so I've got a low point here, and I've got a high point there. Those are my extrema. Which one do you want to do first, the min or the max? The min? Okay, now it says x coordinate, folks. What is the x coordinate of that little valley? What does 3 represent? It's 2003, isn't it? It's not just 3, it's 2003. So then what would you tell me is the x coordinate for my max? 2008. Question. How is what, 2008? The max is way up there. Highest point. Everybody doing? Are you sure you're doing okay there, or no? Are you doing okay? Dalton, you okay? Okay, listen. It's just the x coordinate that I'm looking for. Yeah, read right here. It says, see how it says the x coordinates? Okay. All right. I'm almost there. I'm almost done. The end behavior. This is where I actually get to look at the arrows. Okay. We have the left side and we have the right side. Which one would you like to do first? The left. I'm going to abbreviate it left-hand behavior. If I look at this left side, and that is right there. First of all, on the left side, if I follow this arrow, what's happening to the years? Are the years getting higher or lower? They're getting lower. So I would say in previous years, because that would be before, right? In previous years, what was happening to the retail sales of video games? On the left, they're going lower. The sales were decreasing. Guys, because that's where my arrow points, right? Yes? Now we're going to do the right-hand behavior. So I'm looking over here at this right arrow. Now, as I go to the right, what happens to my x's? What happens to my x's as I go to the right? Come on, you guys know how to graph. As I go to the right, what happens to my x's? They get bigger, don't they? So this would be in future years because the years are getting higher, aren't they? Okay. In future years, what's happening? The sales are doing what? The arrow points up. That arrow points down, doesn't it? Come on, you guys, you got to look at what's in front of you. In future years, the sales will decrease. How'd you do? We're going to do another one. Okay? Sound like a plan? I'm hoping we can get through 2 of them, but I don't know. We'll see. Let's go to the deer problem, please. It's the exact same question with a different graph. What are we going to find first? What's it telling me to find? Where the function is positive. What are we using for positive? Okay, take your red pencil and trace where it's positive. It looks like everywhere, right? Somebody tell me why. Okay, but tell me in the context of this problem, why? The deer population is positive everywhere. Could I have negative deers? No. So there's no way this thing could go under the x-axis. Does that make sense? Okay, what are we using for negative? Where is this thing negative? Nowhere. Because I can't have a negative number of deer. Okay, next we have increasing, and I'm putting that in green. Somebody describe for me where this thing is going up. About 1, she says, to where? To 4. So I'm going to circle that in green. And you just told me from 1 to 4 years, which means the deers were growing. Their population was growing from 1 to 4 years. Then what are they asking me for? Decreasing, and we're using orange for that. Hold on 1 second for me. Where is this thing decreasing? Before, not before 2. Before, this part over here is before 1. Where else is it decreasing? And after 4. Questions for me, guys? Yes, no? We writing it down? Okay, what else am I asking for? Coordinates of what? Of x, of the relative extrema. What are extrema? Very high or very low. Take your regular pencil and put points where it's very high, very low. For what x coordinate is there a minimum? Is there a valley? Say it again. 1 year. Does everybody see how that little valley is on 1 year? Come on. Where is the maximum? At 4 years. Okay, finally, what else do I have to find? The end behaviors. Let's look at the left-hand behavior. On the left side, what happens to the years as I go to the left? They're what? The x's. As I go to the left, what happens to my x's? They decrease. So this would be in previous years, because I have negative years, can I? Folks? No. So in previous years, what's happening to that line on the left? Look at the arrow. What's happening to the line on the left? It's increasing. The population increased. Okay, how about on the right-hand side? What happens to the years as we go to the right? In future years, now I can't just say it decreases here, folks, because can't be negative, can it? So where's it going to decrease to? In future years, it will be 0. Awesome. Awesome. It's a lot of questions to answer in one question, right? Sure? Okay, we're going to do one more. We're going to do the very last one over there. The temperature one. All right, so look at your directions. What is the first thing that you're asked? Okay, now I'm not just going to circle it because those are the directions for all three of those problems, okay? Okay, so what is it? Okay, so I'm going to write, and you guys probably can write underneath it, right? You're going to write linear. Okay. What do they ask me for next? The intercepts. Okay. What's an intercept? Okay, let's start with the x-axis first. Put a dot where this thing crosses the x-axis. Can you tell me what that coordinate is? 5.5 comma 0. Now, folks, remember in that video game problem I didn't use decimals even though it was like halfway between? Could I have half of an hour? Yes, that's why I'm using 5.5 here. Now you have to interpret this. What does this mean, folks? What does that dot right there mean? What do these numbers represent? After how long? Which of those is the x, guys? This is the x, right? After 5.5 hours, the temperature is at 0. I think we're talking Fahrenheit this time. Okay, now I need a y-intercept. 0.45. What does that mean? No. The temperature started at 45. 0 hours is where it starts, right? So the temperature started at 45 degrees. Okay, intercepts are done. Now what are they asking? Is there any symmetry here? No. Okay. Now what are we asking? Okay. What does positive mean? This is where you're using your colored pencils. Red. Circle the positive in red. Positive means above the x, right? That would be all of that. So tell me, describe for me, where is this thing positive? Before 5.5. Okay. Next, we're using blue for what? So circle that negative in blue. Trace the line where it's negative. Now describe for me, where is this negative? After 5.5. So up until 5.5 hours, the temperature is positive. After 5.5 hours, the temperature is negative. Is it okay to have negative temperature? Yes, not like that deer population one where I can't have negative deer. Yes, I can have negative temperature. All right, what's next? And we're using green for increasing. Going up. None. This thing is not going up at all, is it? As I read it from left to right, it is not going up. So what does that mean? The decreasing is everywhere. This whole thing is going down. It is decreasing everywhere. And that was in orange. Okay, I promise we're almost done. What's next? Extremes. What are extremes? Valleys and peaks. There is none. So you're going to say extrema. None. I have no peaks or valleys, folks. Okay. Last but not least, what do I got? Behaviors. Let's start with left-hand behavior. On the left, as the x's do what? As I go to the left, what happens to the x's? As the x's decrease, the y's do what? The y's are increasing because that arrow is pointing up. And we just need right-hand behavior yet. What happens on the right to my x's? As x increases, y decreases. So that one wasn't too bad, was it? No. Okay, so if you need to borrow the colored pencils, please do so. You need to return them tomorrow, though. Your homework is to do this problem. Not number 2, just number 1. Now listen, I want you to use your colored pencils to mark on your notes. But you are going to do your answers on a separate sheet of paper that you're going to turn in to me. I'm going to say it again. You're going to use your colored pencils to mark on your notes on the actual graph. But I want you to write out all of your answers on a separate sheet of paper because you will be turning that in to me. Are we good with that? Yes? Okay, the rest of the time is yours. Go ahead and get started on that. You got about 5 minutes. If you do not need those colored pencils, please put them back.